Hello, everyone. I'm excited to talk about building Google-like site search today. So this is going to be a quick deep dive. We only have 10 minutes, but a quick deep dive in how Google does natural language processing and some of the things you need to think about as you're building natural language site search on your own website. So with that, let's jump into it. Traditional site search is really based off of an algorithm that's very outdated. It's based off of an algorithm. People often call this search. Technically, what it is under the hood is term frequency inverse document frequency. And what it does is it finds documents that contain a keyword the most often. This is what powers most site search today. And what it looks like from a Google perspective in the evolution of Google is what Google looked like closer to 2006, where it's pretty good at finding which documents in a corpus contain a keyword, but it really doesn't meet modern expectations. Specifically, Google's had two huge advancements, the knowledge graph in 2012 and featured snippets in 2016 that really have revolutionized how they think about search. Here are a few examples of what Google search looks like today. So a question, how tall is Mount Kilimanjaro? You're seeing Google is combining different data sets together to provide relevant results. So they're pulling in data from the knowledge graph, they're pulling in FAQs, and they're pulling in organic links. Two more examples. On the left, we see a featured snippet for a question, how do you restart your iPhone 11? On the right, you see that knowledge graph. And you're seeing how Google is mixing and matching different search results into one search UI. Now, there are three key data structures that you need to think about when you're thinking about building site search. There is your structured data. So this is stuff like locations or events or products or jobs or doctors or advisors. Each of these different entities have a lot of structure to them, and you need to search them in a specific way. The next is semi-structured data. So this will usually take the form of FAQs. FAQs are absolutely critical to a good search experience. The final is unstructured data. So this is your blogs, your news, your press releases, your product manuals, and your help articles. Now, it's absolutely critical that your site search can search all this different types of data with these different structures all at the same time. And the key insight that Google has that you need to follow is that depending on the data structure, you want to use a different natural language algorithm. You can't just approach this as locations are treated the same as help articles, which are treated the same as FAQs, and run basic keyword TF-IDF search across that and expect to get good results or expect people to want to use your site search. You need to hit and exceed that Google-like experience if you want to deliver an optimal user experience. So let's talk a little bit more technically about what Google's doing. Here are some examples of Google searching a structured knowledge graph, searching for sports scores or the weather, or location information, or product information. Under the hood, one of the most important natural languages approaches for searching structured data is doing something called named entity recognition. Now, named entity recognition is the process of taking a search, in this example, seasonal stock associate jobs in Atlanta, Georgia, and splitting it apart and understanding what is the intent of each of the terms. So in this case, you want to use named entity recognition to understand that they're looking for seasonal jobs that are stock associate, and the location is Atlanta, Georgia, which has a lat long of 3384. You need to automatically understand these different pieces to the search term and take these pieces of information and turn them into filters so that you can filter down your search results. And you're going to want to use a technique called named entity recognition to do that. The next key data structure that you need to think about is semi-structured data. This is your frequently asked questions, and Google shows frequently asked questions basically every time you run a search. It's an excellent way to show similar searches or to show follow-up questions that a user might have. So how is COVID transmitted? And you see a bunch of related questions to that first question that might better answer the user's question. Or here's another one, how tall is Mount Everest? And here you see a bunch of similar questions that people might ask as follow-up questions to this question. Or do Oreos have dairy? And we see a bunch of options there. Or when is the next iPhone coming out? Now, you see that most of these people also ask, or common questions, have keyword overlap with the search term, but not all of them. For example, when is the next iPhone coming out? You see this question, what will Apple release in 2020? There's no keywords overlapping between these two terms, but any human, any user knows that these are very similar. Apple makes the iPhone coming out. This is maybe a little outdated, still talking about 2020, but this is a very related question. Under the hood, the way you want to search semi-structured data like this is with semantic embeddings. So you don't want to use keyword search to compare FAQs to a search term. Instead, what you want to do is embed both the search term and the FAQs into vector space, and then search based off of similarity. So technically under the hood, you're going to take the search term, you're going to take each FAQ, you're going to embed them as vectors, and then you're going to run a nearest neighbor search across those vectors. Now, there's a lot of different technologies you might use here. To embed the vectors, you might use something like Word2Vec or BERT or Glove. A lot of different options there. For doing the nearest neighbor search, you can do an exact nearest neighbor search or an approximate nearest neighbor search. Something like Elastic's not going to support an approximate nearest neighbor search. So you're going to need to use some other technology. There's companies like Milvus, or actually the Elastic fork from Amazon has an approximate nearest neighbor search you can use. But by embedding the search term and the FAQs into vector space and then comparing based off of semantic similarity, you're going to provide the best results. The final type of data structure you need to think about is unstructured data. This is critical, and you think about blog posts or product manuals or help articles. And here's how Google searches unstructured data. You can see they aren't just showing a link to the article, they're actually extracting the most important word, sentence, or paragraph to be able to provide the results. So where did George Washington grow up? Fairy Farm. It pulled from that paragraph. How to log into Facebook. It pulled these steps right from a Facebook help article. Where did Christopher Columbus land? Here we're just pulling San Salvador right out of this article from National Geographic. Under the hood, in order to do this, this is called unstructured question answering, or extractive question answering, or extractive QA. There's a data set called Squad that you're going to want to think about as the biggest source of labeled data to be able to do this. And you're going to use a technique, a model, maybe BERT or DistillBERT, to actually perform this operation. And what you're trying to do is within a paragraph or within a document, find the most likely word, sentence, or paragraph that answers the question. So overall, it's absolutely critical that you think about these three different data structures and you think about what is the right search algorithm for those data structures. If you have an approach where you treat all different types of data the same and try to run basic keyword search against that, so the traditional site search is crawling every page on the site, treating it all as unstructured documents, and then running keyword search against it, it's not going to be very helpful, and people aren't going to use it. In order to deliver an experience that users want to use, you need to exceed what modern search engines are doing. And modern search engines are using multiple algorithms, all using natural language understanding. And this is what you need to do. I work on the SVP of product at Yext, and this is what our Yext Answers product is focused on, making it so that you don't need to hire your own data science team. You don't need to hire all these natural language understanding experts in order to deliver this site search. So you can focus on the actual content and the data, and we can handle all of these different details around the different algorithms. But if you want to build this on your own, you're going to want to definitely focus on these three core data structures. And these are the three core search algorithms I would start with as you start to think about building a natural language search engine that can mirror or exceed that Google-like search experience. Thank you for your time, everyone. Definitely check out our booth if you have more questions about our product or you want to dive into any of these details even further, and appreciate all the time.